So let's now discuss correlation versus causation. Now, if the correlation coefficient between two variables x and y is positive, then they are said to be positively correlated. Okay. And if the correlation coefficient is negative, then the two variables are said to be negatively correlated. Okay. Right. And the closer the correlation coefficient is to 1 or -1, the stronger the linear relationship. Okay. So as we saw in the previous example, time studying and GPA are pretty strongly correlated, right? So does that mean that if you spend more time studying, your GPA will be higher? It is likely, right? It is kind of intuitive, but that's not always true, okay, for different pairs of variables. Let me show you a few examples. So what I have here is per capita consumption of mozzarella cheese in the US and the number of PhDs in civil engineering awarded in the US from the year 2000 to 2009. Okay. The correlation coefficient between these two variables is 0.96, which is really strong. Okay, but there's no reason to believe that an increase in the per capita consumption of cheese, of mozzarella cheese, has any effect on the number of PhDs in civil engineering. Okay. In this graph, we have the data on per capita consumption of cheese and the number of people who died by becoming tangled in their bed sheets from 2000 to 2009. Okay. The correlation coefficient between these two variables is 0.95. Again, super strong, right? But we shouldn't expect the per capita consumption of cheese to cause people to die by being tangled in their bed sheets. Right? And yet another example, here we have the number of honey-producing bees colonies in the US and the number of juvenile arrests for possession of marijuana, right? From 1990 to 2009. The correlation coefficient between these two variables is negative 0.93, again, very strong, right? But you shouldn't, there's no link really between the number of honey producing bee colonies and the number of juvenile arrests for marijuana possession. Okay? So you probably have heard of the following phrase. People usually say that correlation does not imply causation. Okay. This simply means that the fact that two variables move together does not mean that one causes the other. So you want to be really careful when you look at correlation. So in this video, we looked at a few examples of different pairs of variables with very strong correlation, but seemingly no causal relationship between them. Okay. So what you really want to keep in mind again is that correlation does not imply causation.